Good afternoon, good evening, good morning, whatever time it is for you. We're going to focus in on the next section of Unit 6, Unit 6 being energy resources, and primarily we'll talk about biomass, solar, and wind, and the relative advantages and disadvantages. And it is important that we do understand that there is no silver bullet when it comes to energy resources just yet. They all have both positive and negative consequences. All right. Please do focus in on the Miller textbook to supplement this lecture, sections 15.3 and 15.4, also section 15.6. Lots of good info in there to supplement what we're talking about here. So when we talk about solar energy, first of all, usually when we say solar energy in just general life, we're talking about direct solar energy. So different ways that we use sunlight to directly power a process, and we'll get into that in just a little bit. It's also worth understanding that there are several other energy sources that while we don't often refer to them as solar energy, they are indirectly powered by sunlight. So for example, wind is indirect solar energy because the reason we have wind is because of the heating of the atmosphere at different rates in different places. It creates high and low pressure, it creates wind. Sunlight is what heats that atmosphere, therefore, wind is an indirect solar energy. Biomass, right, uses sunlight to power the process of photosynthesis. So when we burn wood or create biofuels like ethanol or biodiesel, right, indirect sunlight, because in order to grow those plants, it's powered by sun. Hydropower powers the water cycle. The reason we have evaporation from the oceans um, is because we have sunlight. So, but when we say solar power, we're usually talking about things that are directly powered by sunlight. Okay. Um, so the amount of solar resource that we have, of course, varies. It varies with where you are on the planet, with terms of latitude, what time of year it is, and of course, what time of day it is, and climate, which affects how many days you have that are sunny versus cloudy, etc. All right, and then you can look at the U.S. for example, right? Our desert Southwest region, which makes perfect sense, has our highest solar resource. All right. And then, like Western Washington and Western Oregon, for example, where it is often cloudy and rainy, it makes sense that those are our regions with relatively low solar resource. Okay. Well, we kind of squeeze sort of into that moderate solar resource area. So we can use direct solar energy both passively and actively. All right. So passive solar energy is basically something that doesn't require any sort of mechanical device. So we're not uh, using like photovoltaic solar panels to convert sunlight to electricity, for example. Passive solar energy is something as simple as a window that lets in daylight and use the daylight for light in a room, right? That's passive solar energy. Or if you have a south-facing window that's oriented properly to let sunlight in during the wintertime, all right, that contributes to the heating of that space. That's passive solar energy. A greenhouse, right? Passive solar energy. Okay, so it's just simply referring to design features, but they are not like high-tech mechanical devices to directly use sunlight for a purpose. All right. Lots of architecture implements passive technologies to make the most, to make the building less reliant on electricity or natural gas for heating and cooling, um, and more reliant on shade and sunlight during the times of year when they want it. All right. So properly sized overhangs, for example, uh, allow sunlight in the winter when we would like the heat, but shade that window in the summer when we don't want the direct heat from that sun. All right. Now, active solar energy, as I mentioned before, is different ways of harnessing solar energy using some sort of mechanical device. Now, we can use solar water heaters, for example, in which case they're often used as a supplement to a home water heater. So you might have a solar collector of some sort on your roof uh, that it basically collects sunlight and uses that sunlight to warm water up, and that sunlight would then be that water would be pumped through um, and into a heat exchanger, in which case that would heat the water in your home or in a storage tank that gets pumped and cycled through. All right, and that might heat your water up to like maybe 80 or 90 degrees. All right, and then your electric or gas water heater only has to heat the water a few more degrees to get it up to the desired temperature. Okay, uh, so that's solar water heating. It's active because we are using mechanical devices to harness that energy. All right. Um, Now, one of the biggest or most promising things, or what we most of us associate solar energy with, is getting electricity from sunlight. And we do that primarily in two ways, right? What you guys are seeing here is an example of solar thermal electric generation. And this is different from like solar panels that people put on their roof. This is utility scale. So if we wanted to have like a power plant. So rather than a coal power plant, we can have a solar thermal power plant, right? And this works off of the steam turbine system, just like nuclear, just like coal and natural gas, and even geothermal, where we're, you know, having a heat source, right? That heat then boils water to create steam, which spins a turbine, which powers a generator, right? So solar thermal electric generation works in much the same way. All right. But rather than combusting something in the case of coal or natural gas, or rather than running different like isotopes through fission, the heat source in this case is just concentrated sunlight. And so typically the way it works is you have a concave reflective surface that focuses that sunlight on a central point. All right. Inside that pipe right there is usually some form of oil or something that can be heated to a really high temperature without boiling. All right. And that goes to a heat exchanger to create steam. Um, that steam spins a turbine, turbine spins a generator, and it feeds out to a grid. Okay. Um, some of the benefits from this is that it produces basically zero air pollution, um, and there's no contribution to global warming or acid rain in the case, like such as the case with coal. All right. Now, the more common type that we see around here are photovoltaics. So photovoltaics are what we refer to as solar panels usually, right? And in this case, there's no steam, no turbine generation. It is direct photon of sunlight hits the solar panel that causes electrons to move through a conductor. It's a little bit more technical than that, but it's direct sunlight to electricity. So no middle heat exchange process, right? What makes them solar panels particularly useful is that they can be used on essentially any scale. They can be used to power something as small as a calculator, all the way up to grid scale technologies. You just need more of them. All right. And so, like their solar thermal partners, there's no air pollution associated with them, no climate change associated with them, etc. All right. Um, so both of these technologies work well. Solar thermal is grid scale only. You really do this on a small scale. Um, PV can be small scale all the way up to grid scale. All right. But they both share similar downsides or disadvantages, right? And that both of them only produce power during daytime, which makes the storage of that electricity a challenge, makes nighttime a challenge. Okay. Both cases, a lot of space is needed. So, unlike nuclear, which can have very little space footprint, solar electricity has a very large footprint. Okay. Uh, Generally, more expensive in the short term than fossil fuels, right? Particularly just the installation costs and getting it going. Over the lifetime, they definitely pay themselves back in relatively short term, but it is a very large upfront cost to install these systems. Um, and then, as mentioned before, the amount of space we need, right, is a challenge. So to generate electricity on the utility scale, reliable scale, a lot of space is required. And so one of the biggest arguments against grid scale solar systems is, you know, we're likely to put these where it's often sunny, like the desert Southwest, for example. And desert is a pretty important habitat and a fairly fragile habitat. And so if we're installing, you know, tens to hundreds of square miles of solar panels in the desert, that's obviously going to have negative impacts on the desert ecosystem. All right. Now, nice thing is, though, a lot of those downsides of solar electricity can potentially be overcome without really any major technological advances. Uh, Various types of battery storage or hydro storage, uh, et cetera, can overcome the nighttime problem, right? Rooftop and roadside installation um, can kind of overcome the space challenge. So we already have spaces that are being used, right? We can put solar panels on top of those spaces, for example, rather than putting them out into native habitats or unspoiled habitats. Okay. Um, Now, this is a pretty important graphic that we'll probably just take a closer look at in class, but it is worth pointing out that, we look at something like wind, right, is very much cost competitive with other technologies when you look at all the costs associated with it. Solar photovoltaics are a little bit higher, although not necessarily super significantly higher than other technologies, but solar thermal pretty darn expensive along with offshore wind. It makes them a little bit cost prohibitive, but we'll look at those more detail in class. All right, let's move on to wind. Right, this is something we should all be familiar with because we have these wind turbines in and around Walla Walla. Can't really be anywhere in Walla Walla and not have wind turbines within eyeshot. Okay, now wind turbines do operate on a turbine system, but what you're actually looking at, all right, when you see wind turbines, those blades, those are the turbine, right? So instead of using heat and steam, right, we're just simply using the movement of air when it hits these blades that cause those blades to spin. That's your turbine. Inside that turbine is your generator, right? So the direct movement of air spins the turbine powers a generator, that generator then sends electricity out to the grid, power a light bulb or something, right? Now, wind turbines range. A lot of the turbines we have around here are about 600 kilowatts each. It's really common, but the really big wind turbines and offshore wind turbines can be uh, up to 3 megawatts, so 3,000 kilowatts or 3 million watts per wind turbine. Okay? Um, and it is the world's fastest growing source of energy right now, and that's because it is right at that price point that makes it cost competitive, um, and it helps a lot of countries to meet their renewable and clean energy goals. Okay, um, so um, wind energy, I think a really important point. So, obviously we need lots of space for wind energy, similar to like solar energy. But the nice thing about wind energy is we don't actually uh, spoil the land or like cover the land in the same way. So, for example, if we take a look at the wind turbines in this drawing, right? So this is a rural area, so we can use this area for farming. We can use it for ranching or other uses, while also using it for wind. And now that would not be the case if we decided to turn this into a solar farm, right? Much of that space would be covered by those wind turbines, so we wouldn't be able to have multiple uses for that land. Basically, it'd be only solar power. In the case of wind power, you can plop wind turbines on a ranch or a farm and continue to ranch and farm that land and produce electricity at the same time, right? So definitely an attractive endeavor in that case. Plus, it creates extra income for farmers and ranchers. All right. There are relatively few environmental problems with the wind turbines. Now, people don't generally like their appearance, right? Particularly in our natural landscapes, right? It's not a natural feature. Okay. Um, but there is problems if they're not properly sited based on like wind bird migration etc. They can have the downside of killing some of our really important bird species, or even in some cases endangered species. All right. Um, Now, biggest constraint, I put cost here. It's actually not true. They're very much cost competitive, other than the fact that there's the upfront cost of, uh, the initial installation. But they are very much cost competitive when you look at the life cycle of wind turbines. So it's really just the cost of the transition to a new power source. They're not more expensive than other energy sources. All right, but there's definitely public resistance, very similar to our issues with nuclear power. They're obviously not dangerous in a sense, but people just like maybe they like the idea of wind power, but they don't want it in their backyard. They don't, when they look out their window, they'd much rather see a more natural landscape, not these giant wind turbines. Okay, now moving on, we're almost done. We have biomass and biofuels. Okay, so when we talk biomass and biofuels, we're just basically talking about either plants themselves, so wood or other vegetation, or materials that we derive from plants. So, like uh, wood and biomass burning, so like combustion. Much of the developed world still relies pretty heavily on the burning of biomass. All right, so wood pellets, charcoal, other organic materials, because it produces low cost heat and no really like particular special technology. So for cooking, for heating, etc. Now, biomass, of course, is renewable because when we use biomass, we can grow new plants in its place. So as long as we're not using it more quickly, then nature is able to replenish it. It is a renewable resource. Now, there are locations in the world where it is being used a little bit too quickly. Um, So it's led to some over harvesting, but like in our tropical dry forests, like we talked about earlier in the year. And not to mention that burning biomass, anybody who's had a campfire, right, understands that it produces smoke, and that smoke contains particulates, uh, and under the wrong conditions can cause like carbon monoxide poisoning. So when people cook indoors, for example, and it also produces nitrogen oxides, which are contribute to what's called photochemical smog in our cities, um, and can contribute to acid rain. Right now, our biofuels, on the other hand, are liquid fuels such as like ethanol and biodiesel that we derive from plants. And so, what's pretty handy about them is they have the potential to replace things like gasoline, diesel, and jet fuel with a renewable source. So we could use things like algae or other plants to produce oil to basically replace diesel fuel, or we can use things like ethanol or other plants to create another liquid fuel that's combustible. Now, liquid fuels are actually particularly hard to replace because they can vaporize and be combusted. Our liquid fuels can. Uh, and they're relatively dense in terms of how much space they take up and how much energy they do produce. And so liquid fuels are particularly useful for transportation because you can carry a fairly large amount of energy in like a tank, for example, which makes other like solid or gaseous materials a little bit more difficult to manage for transportation anyways. Okay. Um, so biofuels like biomass burning is renewable, right? So we grow the plants, all right, and then we process those plants in a certain way to either produce some oils for like biodiesel or to produce, we ferment them to produce ethanol, etc. All right. So some major advantages. Yes, renewable, and we could kind of consider them carbon neutral in a sense, right? So when we burn them, yes, they produce carbon dioxide, very similar to fossil fuels would. But unlike fossil fuels, we are removing that carbon dioxide from the atmosphere when we grow the plants to create the biofuels. So, yes, we produce carbon out to the atmosphere, but when we grow the plants, right, we pull that back into the plant again. So it's more of a carbon neutral. It's not really the whole story because we're often still using like diesel machinery to grow the plants in the first place, but it's definitely less of a carbon footprint than just directly burning gasoline or diesel fuel. All right. Now, some major disadvantages. Is we have a big increase in land use and water for agriculture because we would essentially be turning a lot of agricultural land to grow to make fuel as opposed to directly growing food. All right. And then, of course, we also have the food issue. If we're converting much of our agricultural land to growing fuel crops, or we're using the food crops like corn to create fuel instead of food, um, that that creates problems or potential food shortages and so on. Not to mention that ethanol, especially, is low net energy, particularly ethanol that we get from corn. Uh, so basically, the amount of energy we have to put into the process to grow the corn, then ferment it, then extract the ethanol requires a lot of energy, and we don't get a whole lot of that. I mean, we get more energy out than we put in, but it's not a super high net energy like other sources would be. All right, that takes us to the end of this session.